All right, everybody, thank you for coming back to my YouTube channel. Welcome to Statistics, Period 4, Mr. Vandrick's class here at school. It's Period 2.
Excellent. Thank you, Leslie F. But I don't want anyone to be confused. We are Period 2. All right? You said Period 4. You're going back to your sophomore year days. It's all good. Throw it back to sophomore year. I love it. It's all good. Here we go. Now we're going to go with this one. Let's keep it going. So, the first slide here is going to introduce you to what we're going to be spending this week, next week, and the week after on. All right? This unit is called the unit on linear regression. All right? So what we just finished before we took that Unit 1 test, we only ever looked at one variable at a time. All right? And in particular, we spent a lot of time looking at one quantitative variable at a time. So I told you guys we focused the most on histograms. We spent a lot of time talking about histograms during that first unit. So this unit is going to look at two quantitative variables at the same time and asking ourselves, is there a linear relationship between the two of them? That's the whole point of this unit. All right, so we're going to practice a lot with Desmos, including today. We'll do some work with Desmos, making a scatter plot. And ultimately, the idea being that we can find a model to predict what we think would happen going forward. All right? Now, when we look at scatter plots, all right, similar to histograms, there's three things we need to look at. We're looking at the direction of the scatter plot of the dots, the form of the dots, and the strength. All right, so those are the three things you need for this unit. What were the three things you knew for last unit for the histogram?
Shape, center, spread.
Shape, center, spread, right? Those three, or you're going to need them, right, on the midterm and on the final, but ultimately we're putting those to the side for now, and we're focusing on direction, form, and strength. Direction, form, and strength. And then, and unusual features, all right? Possible outliers, okay? All right, so let's start with direction. Now, direction, pretty much the only options you're going to see here are positive or negative. Okay? So if you think back to your days of an algebra, if you're going from the top right to the bottom, the top left to the bottom right, like what's happening in this scatter plot, you would say that it has a negative direction. If our dots went from the bottom left to the top right, what I just plotted there, that would be a positive direction. All right, so that's what we're really looking for when we say direction. Any questions on direction, right? And hopefully you've already done this on your notes.
Oh my God. We gotta sing the song.
Okay. Any questions on direction? No questions on direction? Excellent. What's your question about one direction? Because I don't know it. I don't know. That's a question for Zane, right? Nice. They wanted to go one direction, but he wanted to go the other direction. Someday they'll come back together. How many years has it been? Yeah, right? I know. I'm sad too, every day. That's why it's raining. All right. Everybody good on direction? Okay. Let's go to form. Now, there are a couple different options you have for form, but really the main ones I want you guys to think about for form are linear or not linear. All right, this unit is about linear regression. So hopefully, when we do a problem, we think that the scatter plot looks linear. Because if it doesn't, are we going to do linear regression? No. All right, I'm telling you that right now. If it doesn't look linear, like this one over here, looks curved or not linear, we would not be using any type of linear regression stuff on that one. All right, so this one over here, if you're using any of the things that we're going to learn over the next few weeks with that scatter plot, if anyone looked at your results, they'd be like, wait, hold on, why did you do all this? That's not even linear. Okay, so that's kind of like the first thing we need to happen. Is it linear? Now, I'm not going to really teach you this in this intro stats course, but if you take a stats course in college, they'll teach you how to re-express some of the data, like change some of the data, that will allow you to use what we're going to do with this linear regression to change the scatter plot to make it look linear. All right, we're not going to do that in this course, but it could happen in your college course. I circled this one because this one is not linear, right? So all the stuff I'm going to teach you to do, Leslie F., you would not do it for this one because this one is not linear. She's out there. She's going to listen to this, and she's going to be really mad if I didn't say Leslie F. Okay, so I'm sorry, Leslie A. You good, Jarvis? Yes. All right, man.
You say my name. I want to be famous.
Catherine with a K? Spelled correctly? Okay. Unless you changed it. Your name would then be CC. That'd be pretty cool, right? Catherine Castaneda, CC, C squared. Right? All these cool nicknames you could have. Now it's just KC, Kansas City. That's not really as fun, right? What up, KC? Oh, that's actually not bad. I like that. KC. Is your middle name start with an F?
Starts with an A.
Well, that doesn't work now. I'm going to keep going. So, the last one is strength. All right? Now, this one, you've got some options here. The words that statisticians use are strong, weak, or moderate. Strong, weak, or moderate. Okay? Now, if you look at this one, I know you're focused on the fact that the dots are just bigger. Try to ignore the fact that the dots are bigger. Do you see how they're tighter together in this linear form? All right, this would have a strong relationship, a strong linear relationship. This one to the right, I know the dots are smaller. This has nothing to do with it. See how you can't really tell the direction it's going? Like, oh, is it positive? Is it? I don't really know. It's a cloud. All right, if you see a cloud-like scatter plot, that's going to be weak. This is going to be weak. All right, weak. The strength of this would be weak. Okay? Now, you're going to see as we practice, and on the homework, you're going to practice this too. All right, I'm so happy I made that homework. I can't tell you how excited I was to make that. All right? But you're going to practice, so we're going to practice on the Kahoot later this week. You're going to see and get better at looking at something and saying if it's strong, moderate, or weak. Okay? Yes, John.
What would moderate?
Some of my dots are disappearing. Where it's like going, wow, that's really helpful. Where it's going positive or negative, so you can clearly tell. Where'd it go? Did it keep it? Oh, that would have been so awesome if it had kept it. I'm not going to do it again because that was clearly a sign that it said don't do that. This is weak. This is like a cloud. That's strong, so be something in between. So more space in between the dots. That's what I'm trying to show you, and then OneNote said no. Okay? Everybody, trust me, we're going to do a lot of practice. And on your homework, it happens too. Okay, let's keep going. Now, I did mention that we will have unusual features from time to time, possible outliers. All right, so you're always looking for that, but you've been looking for outliers or possible outliers for a while now. So let's get into actually what we need to do to make a scatter plot. The first thing we have to do is decide which one is going to be our explanatory variable, which is going to go on the x-axis, and which variable is going to be our response variable, which goes on the y-axis. Okay? And we're going to practice one today together using Desmos to make our first ever scatter plot. All right? It'll be a great time. Now, I know in some classes, especially the science classes, you guys have probably used, especially some of you are environmental science, you might use independent and dependent for your variables. I will not be using those words. All right? Independent and dependent, we use in statistics in a different way. You've already had the first experience of saying if two things are independent, then they have no relationship. So I will not be using those again because it'll just confuse you. All right? So we're going to be focusing on explanatory, which here, think of it how I'm saying it. Ready? Explanatory is the X one. All right? And response is what it spits out. That's the Y. All right? We'll practice it time. Okay. Okay, correlation. All right, so this is a word that I hear all the time in meetings and going around talking with other people, just in watching TV, I hear the word correlation used socially, all right, incorrectly. All right, correlation should only be used if you've satisfied all of these conditions. Okay, so the first thing we're going to ask ourselves today, are the two variables quantitative? If you can't think of the units for each of them, then they're not quantitative. Now again, today, and all the examples we do this week, they're going to be because we want to practice. But in the future, like on a test, and you're trying to do like on a final, you don't know what you're doing, you want to ask yourself, what kind of variables do I have here? The straight enough condition is just a fancy way of saying is, when you check the scatter plot, does it look like a line? Did you say linear for the form? Because if you didn't say linear, remember that curved one? We should not be using any of the stuff that we're going to talk about, including the word correlation. And then finally, the outlier condition. Really, you want to make sure there's no outliers. If there are outliers, you can report the correlation coefficient with and without those outliers. Okay? So the big thing you're going to hear from me this week is correlation coefficient is only measuring the strength of the linear relationship. So it's all about the linear relationship. So it's a really powerful statistic, but it's limited because it can only measure a linear relationship. Any questions on correlation? So if I hear you use the word correlation in this room, talking about statistics incorrectly, I will correct you. All right? Like I've been in meetings where teachers are talking about a relationship between two variables that are not quantitative, and they'll use the word, well, they're correlated. And in my mind, I go, they're associated. One time I did. One time I said, I'm sorry, actually, since we're talking about data here, correlation is actually only for quantitative variables, and what you're talking about is categorical, so it's not really appropriate. You should use the word association.
Bro.
Well, that's not. I'm not going to put them on blast, right? Come on now. All right? Right is right.
Did they correct themselves afterwards?
I think it was more of like, no, I'm not sure that was the response I got.
That wasn't
I think the response was, okay.
Okay.
All right, so let's talk about some of the properties of correlation coefficient. Remember, if you saw on the last slide, this is always the lowercase letter r. So anytime you're reading anything that has some type of statistical context and you see a lowercase r, that is telling you that it's the correlation coefficient. It's measuring the strength of the linear relationship. First thing I want you to know is that it should always be between -1 and 1. So if you see an r and it says r equals 2.5, immediately you know something's wrong. Or they're not talking about correlation coefficient. They're talking about something else, some other variable they're using for r. All right, but since we're in statistics, if I'm writing about statistics, I'm never going to use r except for correlation coefficient. Okay. Now, I mentioned that we have strong, moderate, and weak. Those are the most common ones used. So if you have an r that's close to 0, so approximately 0, whether it's a -0.1 or a +0.1, that would be weak. All right. I'm going to give you kind of arbitrary breaking points, if you will, for where I move from weak to moderate and moderate to strong as we go on this week. That was pretty good. No, weak. And
I'm writing. What do you understand?
homophones. Yeah, that's right. Homophones, when they're spelled, they sound the same, but they're spelled different.
Yes.
Yes. What? Oh, English, man. Good times. Okay. Now the last part is really harkening back to our last unit. These last ones here. Couple of things. Correlation has no units. So if you ever see anyone say the correlation coefficient is 0.6 inches, well, that's just wrong. Okay, cannot have units. Do you remember when we talked about taking all of your data values and adding 20, or taking all of them and dividing by 2, changing the scale? It does not affect correlation coefficient. All right, and then you can see here, the way they calculate it is based on z-scores, standardizing. And remember from our last unit, our review, that if you change the scale, your z-scores don't change. That was one of the questions on the review. Okay, so all that's based on the same thing. We are never going to calculate correlation coefficient by hand. It's not even worth trying it one time. Okay, it's that confusing. All right, I'm not going to show you the formula because it's going to make you sad. Okay, so we're not going to do it.
I kind of want to see it.
No.
Can we can't even see it. Yeah, you have visible on your own. Yeah, we can switch on.
There you go. I like that. GTS on your time. Now, in terms of the last couple of correlation properties here, I put it again, but we've already mentioned this. I'm trying to be very precise when I tell you this, and I want to be very clear that correlation only measures the strength of the linear relationship. That's why it's there again. Only about linear relationship between two variables. All right, so you're going to see this week that we're going to have variables that have a strong relationship, but it might have a correlation coefficient close to 0 because it's all about the linear one. Like, for example, I like using this one. Maybe the dots will stay this time. Right? If you look at those dots, you should see that looks like a quadratic. It's a parabola. Right? So the R for this would be, close to 0. It's not linear, but that has a very strong relationship. It's just not linear. Okay? So again, that's not really helpful for this unit. All right? Correlation does respond to outliers, so if you have outliers, please report it with and without. This is the most common thing that gets messed up in the world when I listen. That's not true, right? But it's a common misconception that I hear all the time. All right, not just in the building or in this classroom, but just in the world. I always hear people talk about when they find out that two quantitative variables have a positive or a negative strong correlation, then they go to that next step of, oh, well, this causes that. All right? So I want to be very clear, I'm going to say this a lot, that just because you find something that has a strong linear relationship does not mean that there's a cause and effect relationship. Oh, yeah, you guys doing that in environmental science? Excellent. I should talk to Mr. Fee. All right, dean, assistant dean, associate dean, whatever, dean. Assistant to the dean fee. Got it. Okay, so.
No, not doctor yet.
Is he becoming a doctor? I didn't know he's taking PhD classes.
He's going to, we're making.
Like right now he is?
No, we're going to make.
Well, that's very different than saying that he's currently enrolled in a doctorate program. Anyway, this word, lurking variable, is going to happen as we move forward in the next few weeks. I want you to be very careful when you find two things that have a strong linear relationship. There could be something else that we can't see or what's in the background, lurking, if you will, that's causing what's happening. Okay, we'll talk more about that the next few weeks. Okay, any questions? I think that's it, right? Yes. All right, the outro, Leslie. F.
All right, gamers. Thank you so much. See you next time. Subscribe. Don't forget to like and subscribe.